Okay, we're on to section 7.6, part 2, which is the homework was page 456 to 457, 38 to 58 even. I will be doing 37 to 57 odd. Alright, the first problem says the square root of x plus 4 equals the square root of 2x minus 5. So this is an equals here and a minus here. Okay, so first step says we need to make sure we have a radical isolated on a side, which we do, so that's going to make our life easier. Now that we have our radical isolated, we can go ahead and square both sides. Make sure to draw your parentheses. The square root and the square on both sides cancel actually, leaving us x plus 4 is equal to 2x minus 5. Okay, in order to solve for x, I have to have all my x's together. I'm going to subtract x from both sides to keep my x's positive. That's going to leave me 4 equals x minus 5. And then I'm going to add 5 to both sides, leaving me x is equal to 9. Now that I have that, I need to plug it back in and make sure that I am correct. So I'm going to plug back into the square root of x, which we said is 9, plus 4 equals the square root of 2x, which again we said is 9, minus 5. Okay, let's go ahead and see if it works out. 9 plus 4 is 13. Square root of 13 equals 2 times 9 is 18. So we have the square root of 13 is equal to 18 minus 5 is 13. Is the square root of the square root of 13 equal to the square root of 13? It sure is. So therefore x equals 9 is a good answer. And our only answer. Let's go ahead and move on to the next one. The next one says x minus the square root of 1 minus x is equal to negative 5. Okay? So, in order to be able to do this, remember I have to isolate my radical on one side. So I'm going to need to subtract x from both sides. That's going to leave me negative square root of 1 minus x is equal to negative 5 minus x. I'm going to go ahead and divide by negative 1 on both sides, which is going to cancel my negative out in front of this radical so I don't get confused. So I'm going to have square root of 1 minus x, and then on this side, if I bring my negative up into the numerator, all that does is change my signs in my numerator. So that leaves me 5 plus x. It looks like this. If I say negative times negative 5 minus x, you distribute the negative through, leaving you 5 plus x, which is where I got that from. Okay, now that I have my radical isolated on one side, I can go ahead and square both sides. Make sure that you're using your parentheses because you are squaring a binomial here. The square root and the squared cancel, leaving you 1 minus x is equal to 5 plus x times 5 plus x. Okay, 1 minus x we're going to leave alone for now. 5 plus x times 5 plus x ends up being 25 plus 5x plus 5x plus x squared. 5x and 5x are like terms, so I can go ahead and add them together, giving me 10x plus x squared. This x squared immediately tells me that in the end I'm going to have to factor in order to solve, and in order to factor I need to set my equation equal to 0. So I'm going to move everything from the left side to the right, which involves me adding x to both sides. These cancel here, leaving me 1 is equal to 25 plus 11x plus x squared. Then I'm going to subtract 1 from both sides, giving me 0 equals 24 plus 11x plus x squared. Now, just like in the problems yesterday, I'm going to go ahead and rewrite this into what a problem normally looks like that we're dealing with when we factor. Okay? Now I'm going to have to go through my steps of factoring. Remember, you always multiply your first and last number together, which gives you 24 in this case. Then I need my factors of 24 that give me 11. Which ones can give you 11? 3 and 8. So I'm going to go ahead and build my houses. Each house gets an x. Bring down my first sign. If my first sign is plus, I keep my second sign. Always write your larger number first, so I'm going to go with the 8 first and then the 3. Look at each house and see if they have anything in common. X and 8 don't have anything in common, neither do x and 3, so I can go ahead and move on to solving. And in that, you'll go ahead and set each house equal to 0. So here you'll subtract 8 from both sides, giving you x equals -8. Here you'll subtract 3 from both sides, giving you x equals -3. I don't really understand why it does that. Okay, so now let's go ahead and plug in x equals -8 and x equals -3. My original equation was x minus the square root of 1 minus x equals -5. Okay, so let's go ahead and let's try -8 first. Everywhere there's an x, I'm going to put -8. Be careful with your parentheses there because it's minus a negative, which will eventually change to a plus. Add a line, change the sign. 1 plus 8 is 9. Square root of 9 is 3. Is -8 minus 3 -5? No, -8 minus 3 is -11. So you can immediately eliminate x equals -8. Alright, now that we figured out that -8 is not an answer, let's try -3. So -3 minus the square root of 1 minus -3 equals -5. Let's draw a line here so we don't get confused. -3 minus the square root, add a line, change the sign, of 4 is equal to -5. -3 minus the square root of 4 is 2. Is -3 minus 2 -5? It sure is. So x minus 3 is a good answer. I'm sorry, x is -3 is a good answer. Okay. Alright, 41 says cube root of -6x minus 1 is equal to the cube root of 2x minus 5. -2x minus 5. Okay. We have radicals isolated on each side, so we can go ahead, on this one we're going to take a cube to get rid of our cube root on both sides. Cube root and cube cancel, cube root and cube cancel, leaving you -6x minus 1 is equal to -2x minus 5. Okay, we need to get all of our x's together. I'm going to add 6 to both sides to make our x's positive, leaving me -1 is equal to 4x minus 5. Then I'm going to add 5 to both sides, leaving me -4 is equal to 4x. I'm sorry, positive 4, silly me. Divide both sides by 4, and you get x is equal to 1. Okay, let's plug it back in and see if it works. Cube root of -6 times 1 minus 1 is equal to the cube root of -2 times 1 minus 5. Alright. -6 times 1 is -6 minus 1 equals the cube root of -2 times 1 is -2 minus 5. Alright. Cube root of -6 minus 1 is -7. Cube root of -2 minus 5 is -7. Those are the same, so we know that x equals 1 is a good answer. Okay, number 43 says the square root of 5x minus 1 minus the square root of x plus 2 equals 3. Now, in order to be able to solve any of these, I have to isolate one of the variables, either here or here on the left side. Doesn't matter which one, but you have to isolate one of them. So first I'm going to go ahead and move the 2 over to the other side. So I have the square root of 5x minus 1 minus the square root of x is equal to 1 because 3 minus 2 is 1. Now I'm going to move this square root of x over to the other side so that this square root of 5x minus 1 is by itself. So I'm going to add square root of x to both sides, which leaves me the square root of 5x minus 1 is equal to 1 plus the square root of x. Now that I have my radical isolated, I can go ahead and square both sides. This square root and this square cancel, leaving me 5x minus 1 is equal to, this is 1 plus the square root of x times 1 plus the square root of x. So I'm going to go ahead and FOIL or double distribute the right side, which is going to give me 1 plus the square root of x plus the square root of x plus the square root of x squared. Let's clean it up a little bit. You have 5x minus 1 is equal to 1. Both of these square roots of x are like terms, so I can add them together, plus 2 square root of x plus this square root and this square cancel, leaving me just plus x. Now that I've gone through all of that, I still have a radical left. Because I still have a radical left, I have to isolate this radical and then solve that way. So now I'm going to move everything else from the right side, other than the radical, to the left. So I'm going to start with subtracting x from both sides. That leaves me 4x minus 1 is equal to 1 plus 2 square root of x. Then I'm going to subtract 1 from both sides. Which is going to leave me 4x minus 2 is equal to 2 square root of x. Now, you have two options with what you can do here. You can either go ahead and square both sides now, or you can divide 2 from both sides and then square both sides. It's up to you. I'm going to go ahead and square both sides now. So this becomes 4x minus 2 times 4x minus 2. When I take 2 squared, I get 4. And when I take the square root of x squared, the square root and the square cancel each other, leaving me just x. So I'm just left with 4x. So now I need to double distribute or FOIL the left side. So I have 16x squared minus 8x plus 4 is equal to 4x. If I notice negative 8x and negative 8x are like terms, I can go ahead and combine them, giving me negative 16x plus 4 equals 4x. This squared is a dead giveaway that I'm going to have to factor at some point, so I need to go ahead and subtract 4x from both sides so that my equation is set equal to 0. So that gives me 16x squared minus 20x plus 4 equals 0. Now that I've done that, I can go ahead and factor. First rule of factoring says, look at all of my terms and see if they have anything in common, and if they do, factor it out. All of these, 16x squared, negative 20x, and 4, all have a 4 in common. So I can go ahead and factor that 4 out front, leaving me 6. Just kidding. If I factor out a 4, I'm left with 4x squared minus 5x plus 1 equals 0. Divide both sides by 4, and you're left with 4x squared minus 5x plus 1 equals 0. Now we have to factor. Alright, so I'm going to go ahead and build my houses. You multiply your first and last terms together, so you get 4. Your factors of 4 are 1 and 4 and 2 and 2. Which one's going to give me 5? 1 and 4. So both houses get a 4x. Keep your first sign. If your first sign is negative, you change your second sign. Always write your larger number first. Look at your houses, see if they have anything in common. This house has a 4 in common, so this becomes x minus 1. This house doesn't have anything in common, so it stays 4x minus 1. Once you've factored, you go ahead and set each house equal to 0. I'm going to add 1 to both sides, leaving me x equals 1. And then I'm going to set 4x minus 1, the other house, equal to 0. Add 1 to both sides, leaving you 4x is equal to 1. Divide both sides by 4, and you get x is equal to 1/4. Alright, I'm going to go ahead and move some of this stuff up out of our way so that we can just check our answers. Alright, so I have x equals 1 and x equals 1/4. So let's try x equals 1. The original equation was the square root of 5x minus 1 minus the square root of x plus 2 equals 3. So let's plug in 1. The square root of 5 times 1 minus 1 minus the square root of 1 plus 2 equals 3. 5 times 1 is just 5, leaving me 5 minus 1 under the square root, and the square root of 1 is just 1. Square root 5 minus 1 is 4, so you have the square root of 4. Negative 1 plus 2 is positive 1 equals 3. The square root of 4 is 2. Is 2 plus 1 3? Yes, it is. So we know x equals 1 is a good answer. Now we need to try x equals 1/4. Alright. So the original equation again was square root of 5x minus 1 minus the square root of x plus 2 equals 3. So we're going to plug in 1/4 everywhere there's an x. Square root of 5 times 1/4 minus 1 minus the square root of 1/4 plus 2 equals 3. Alright, if I put my 5 over my 1, I can just multiply fractions straight across, which just gives me the square root of 5 over 4 minus 1. Minus, I can use the quotient rule to break up my radical, square root of 1 over the square root of 4 plus 2 equals 3. And this benefits us because we know the square root of 1 is 1, and we know the square root of 4 is 2. We may not know that the square root of 1/4 is 1/2. Alright, in this radical, I'm going to need a common denominator. That common denominator is 4. Go ahead and put your 1 over 1. This fraction doesn't change at all. 1 goes into 4. 4 times 1 is 4. Or you can say times 4 with each one. Minus the square root of 1 is 1. And the square root of 4 is 2. So it's minus 1/2 plus 2 equals 3. Now we're going to have the square root of 5 minus 4 over 4. 5 minus 4 is 1 minus 1/2 plus 2 equals 3. So we'll do square root of 1 over the square root of 4 minus 1/2 plus 2 equals 3. Square root of 1 is 1. Square root of 4 is 2. So you have 1/2 minus 1/2 plus 2 equals 3. 1/2 minus 1/2 is just 0. Does 2 equal 3? Nope, it does not. So 1/4 is not a good answer. So our only answer is x equals 1. Okay, here we have the square root of 2x minus 1 equals the square root of 1 minus 2x. Okay, so I can go ahead and square both sides since my radical is already isolated. Square root and square cancel on both sides, leaving you 2x minus 1 is equal to 1 minus 2x. I want to keep my x's positive, so I'm going to add 2x to both sides, leaving me 4x minus 1 is equal to 1. Now I need to add 1 to both sides. 4x is equal to 2. Divide by 4. X is equal to 2 over 4, but we don't just leave 2 over 4, we reduce it to 1/2. Now we need to plug in 1/2 to see if that's going to work out for us. So I have 2 times 1/2 minus 1 equals the square root of 1 minus 2 times 1/2. And this actually works out pretty nice for us. If you put your 2 over 1, you can see that these just cross-cancel each other, leaving you the square root of 1 minus 1 equals the square root of 1 minus, if I do the same thing here, my 2's cancel, leaving me just the square root of 1 minus 1. And you can see at that point that they're the same on the left and the right. So you know that x equals 1/2 is a good answer. Now we have the square root of 3x plus 4 minus 1 equals square root of 2x plus 1. All right, in order to be able to go ahead and start, I need to make sure that I have a radical isolated on one side of my equation. On this side, I have a minus 1 with my radical. But on this side, I have a radical all by itself. So it's okay if it's the right side. It doesn't matter what side the radical's on. So at this point, I can go ahead and square both sides. Make sure you put your parentheses around everything. So this is technically the square root of 3x plus 4 minus 1 times the square root of 3x plus 4 minus 1. That's a binomial squared. Equals, here my square root and my square cancel, leaving you 2x plus 1. Okay, we're going to have to FOIL or double distribute the left side. So the first thing is going to be the square root of 3x plus 4 squared minus the square root of 3x plus 4, you don't need the 1, minus the square root of 3x plus 4 plus 1 equals 2x plus 1. Your square root and your square cancel here, leaving you 3x plus 4. And negative square root of 3x plus 4 minus the square root of 3x plus 4 is negative 2 square root of 3x plus 4. And then you have plus 1 is equal to 2x plus 1. All right, we still have a radical. So we're going to have to isolate the radical and then solve after that. So we need to get everything away from this radical here. So the first thing I'm going to do is combine this plus 4 and this plus 1 because they're like terms. So you have 3x plus 5 minus 2 square root of 3x plus 4 is equal to 2x plus 1. Now let's go ahead and start moving things away from the radical. So I'm going to subtract 3x from both sides. That's going to give me 5 minus 2 square root of 3x plus 4 is equal to 2x minus 3x is just negative x. And then you have a plus 1. And then I'm going to subtract 5 from both sides, which gives me negative 2 square root of 3x plus 4 equals negative x minus 4. Okay, you have two choices here. You can either go ahead and square both sides at this point, or you can divide negative 2 from both sides. I'm going to square both things at this point. So make sure you use your parentheses when you square both sides. On the left side, when you square, you get negative 2 squared is 4. And then the square root of 3x plus 4 squared, your square root and your square cancel each other out, which leaves you just 3x plus 4. Make sure you write your parentheses so when you distribute, so you actually know that you need to distribute the 4. And then on the right side, you have negative x minus 4 squared, which is negative x minus 4 times negative x minus 4. Do not just square both pieces. It's a binomial squared. Here you can distribute your 4, which is going to give you 12x plus 16. And then on this side, you're going to either double distribute or FOIL, whichever one you call it. So you have negative x times negative x is positive x squared. Negative x times negative 4 is positive 4x. Negative 4 times negative x is positive 4x. And negative 4 times negative 4 is positive 16. You can go ahead and combine your 4x's here because they are like terms. So you have 12x plus 16 is equal to x squared plus 8x plus 16. That x squared should be a dead giveaway that you're going to need to factor. So we need to move everything from the left side over to the right so my equation is set equal to 0. Because you cannot factor until your equation is set equal to 0. So I'm going to subtract 12x from both sides, leaving me 16 is equal to x squared minus 4x plus 16, and then I'm going to subtract 16 from both sides. That actually cancels on both sides, which just leaves me 0 equals x squared minus 4x. So we don't have to do our typical 8 steps of factoring. Here we can just go ahead and factor out an x, which leaves me x minus 4. You'll set each piece equal to 0. So you have x equals 0, and then x minus 4 equals 0. Add 4 to both sides, leaving you x equals 4. So I have x equals 0 and x equals 4. I need to go ahead and plug those in to make sure that they both work. Alright, our original equation was the square root of 3x plus 4 minus 1 equals the square root of 2x plus 1. Alright, so let's try 0 first. So plug 0 everywhere there's an x. 3 times 0 plus 4, square root of 3 times 0 plus 4, minus 1 equals the square root of 2 times 0 plus 1. 3 times 0 is 0. 0 plus 4 is 4, so it's the square root of 4, minus 1, equals 2 times 0 is 0. 0 plus 1 is 1, so it's the square root of 1. Square root of 4 is 2, and the square root of 1 is 1. Is 2 minus 1 1? Yes, it is. So x equals 0 is a good answer. Now let's plug in 4. So everywhere there's an x, I'm going to put a 4. 3 times 4 plus 4 minus 1 is equal to 2 times 4 plus 1. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 minus 1 equals the square root of 2 times 4 is 8. 8 plus 1 is 9. Square root of 16 is 4. Square root of 9 is 3. Is 4 minus 1 3? Yes, it is. So x minus 4 is also a good answer. So in this set, we're actually going to be able to write two numbers, which is nice. So your answer is 0, 4. Alright, number 49 says the square root of y plus 3 minus the square root of y minus 3 is equal to 1. Okay? In order to be able to start solving, I have to isolate one radical on one side or the other. So I'm going to go ahead and isolate this radical by moving this one to the right side. So I'm going to add the square root of y minus 3 to both sides, which is going to leave me the square root of y plus 3 is equal to 1 plus the square root of y minus 3. Now I'm going to square each side to cancel this square root. When I square the right side, I'm going to have to FOIL. The square root and the square cancel, leaving me y plus 3. And this is 1 plus the square root of y minus 3 times 1 plus the square root of y minus 3, because it's two binomials being multiplied together. So I'm going to go ahead and have to distribute the second half. So 1 times 1 is 1. 1 times the square root of y plus 3 is just the square root of y plus 3. I'm sorry, minus 3. The square root of y minus 3 times 1 is just the square root of y minus 3. And then the square root of y minus 3 times the square root of y minus 3 is the square root of y minus 3 squared. Your square roots of y minus 3 are like terms, so I can combine them, leaving me 1 plus 2 square root of y minus 3, because there's two of them, plus your square root and your square cancel, leaving you just y minus 3. Now we have a like term of 1 and negative 3, so I can combine those. Y plus 3 equals 1 minus 3 is negative 2, plus 2 square root of y minus 3 plus y. So that was 1 minus 3 to give us the negative 2. Now we're in a situation like before where we still have a radical, so we need to isolate it by moving the y and the 2 over to the left side. So I'm going to subtract y from both sides. These cancel, leaving me 3 is equal to negative 2 plus 2 square root of y minus 3. Now I'm going to add 2 to both sides. Which is going to leave us 5 equals 2 square root of y minus 3. Okay, you can do two things at this point. You can either square both sides now, or you can divide both sides by 2. I'm going to square both sides now, which is going to give me 25 is equal to 2 squared is 4, and the square root of y minus 3 squared, your square root and your square cancel, leaving you just y minus 3. Make sure you put parentheses around it so you know to distribute your 4. Actually, we're not even going to distribute the 4. We're going to divide the 4 away in order to isolate y. So that's going to leave me 25 over 4 is equal to y minus 3. Add 3 to both sides. So you have 25 over 4 plus 3 over 1 is equal to y. You need a common denominator in order to add fractions. The common denominator is 4, so therefore your first fraction doesn't change. The second fraction, 1 goes into 4 times. 4 times 3 is 12. Or you could have said times 4 times 4. You have a common denominator of 4. 25 plus 12 is 37. So y is 37 over 4. Now we need to take 37 over 4 and we need to plug it into the original equation. The original equation said the square root of y plus 3 minus the square root of y minus 3 is equal to 1. So wherever there's a y, I'm going to plug in 37 over 4. 37 over 4 plus 3 minus 37 over 4 minus 3 equals 1. Go ahead and put your 3's over 1 because you're going to have to go ahead and add fractions. Your common denominator for this square root is going to be 4. So your first fraction doesn't change at all. Your second fraction, 1 goes into 4 4 times. 4 times 3 is 12. Or you could have just said times 4 minus this square root. The common denominators are also going to be 4. First fraction stays the same. 1 goes into 4 4 times 3 is 12. Or you could have said times 4 equals 1. So it is the square root of 49 over 4 minus the square root of 49 over 4 equals 1. I'm sorry. Back that up. You're subtracting on this one. 37 minus 12 is 25. So now you'll say the square root of 49 over the square root of 4 minus the square root of 25 over the square root of 4 equals 1. The square root of 49 is 7. The square root of 4 is 2. The square root of 25 is 5. The square root of 4 is 2 equals 1. I'm going to scoot over here a second. So you have common denominator of 2. 7 minus 5 is 2. Does 2 over 2 equal 1? It sure does. So your answer of 37 over 4 is correct. Number 51 has a triangle that looks like this. And it says this side is 6 feet and this side is 3 feet. And the directions are they want us to find the unknown side. When you're dealing with right triangles, you can always use the Pythagorean Theorem. Just ignore this for right now. We know the Pythagorean Theorem is a squared plus b squared equals c squared. Remember, a and b are sides, and c is our hypotenuse. C is always the side across from the right angle. It's always your diagonal side, okay? So one of the most important things to remember when dealing with the Pythagorean Theorem is C always has to be the hypotenuse. Other than that, A and B are pretty much interchangeable. So you can decide for this to be A and this to be B, or this to be A and this to be B. Those don't matter. All that matters is that C is always your hypotenuse when you go to plug into the formula. So in order to solve for the unknown side, what we're going to do is we're going to decide which one of these we want to be A and which one we want to be B. So, all right, make this one A if you want to, and then make this one B. It doesn't matter with A and B. They're interchangeable. So A is going to be 3 squared plus B squared will be 6 squared, and C is what we're trying to find. 3 squared is 9. 6 squared is 36. 9 and 36 is 45. So 45 is equal to C squared. However, I don't want to know what C squared is. I want to know what C is. So I'm going to take the square root of both sides because the square root and the square cancel each other. So C is equal to the square root of 45. Except every time that you're talking about a distance, you need to make sure that you put it in its simplest form. So I need to see if 45 can simplify to anything. So 45 is 9 times 5, and 9 is 3 times 3. So I know, since I have 2 3s, I can bring a 3 out front and leave a 5 in the inside of the radical. So C is 3 square root of 5. All right, number 53, the triangle looks like this. And they want you to find this side. So we're going to call this side B, which makes this side A. And remember, the hypotenuse is always C. So when we go to plug in to A squared plus B squared equals C squared, 3 is A, so 3 squared plus B squared, and C is 7, so 7 squared. 3 squared is 9, and 7 squared is 49. I'm going to subtract 9 from both sides, and you get B squared is equal to 40. Square root both sides to get rid of this squared, because I don't want to know what B squared is, I want to know what B is. B is the square root of 40. Let's see if we can simplify this. 4 times 10, 4 is 2 times 2, and 10 is 2 times 5. I need 2 to be able to pull a number out front. So I'm going to bring 2 out front and then leave 10 on the inside. And don't forget your unit. So it's 2 square root of 10 meters. Okay. The triangle for 55 looks like this. And has 9 meters here and 11 square root of 5 meters here. And we're going to say this one's B, this one's A, and this one's C. All right, so again, A squared plus B squared equals C squared. So A is 9, so 9 squared plus B squared is equal to 11 square root of 5 squared. 9 squared is 81 plus B squared equals 11 squared is 121, and the square root of 5 squared is just 5. Because your square root and your square are going to cancel out. So I have 81 plus B squared is equal to 605. That's 121 times 5. Subtract 81 from both sides, and you get B squared is equal to, we've got 4, we got 2, and then we got 5, so it's 524. But again, I don't want to know what B squared is, I want to know what B is. So I need to square root both sides to get rid of that squared. The square root and the square cancel, leaving you B is equal to the square root of 524. Now I'm willing to guess that 524 can be simplified. So let's go ahead and see what we can do. All right, let's break 524 down. 524 is 131 times 4. 4 is 2 times 2. 131 is actually a prime number, so we can't factor it any further. So I've got a 2 that I can bring out front, and 131 left in the radical. And this one is meters. Now, on number 55 through 58, they asked for an exact length, which means 2 square root of 31 is not going to do. Obviously, if someone wants to know an exact length of something, if you tell them 2 square root of 131, they're not going to have any idea what you're talking about. So just go ahead and plug it into the calculator, and you get B is approximately 22.9 meters. It's important that you can not only simplify and give a simple radical, but that you can also plug it into your calculator and give an exact length. All right, and the last triangle, 57, looks like this. Oh, that was a terrible right triangle, but you get the idea. So we have 7 millimeters and 7.2 millimeters. Okay, so we obviously need to find this side here, and this is the hypotenuse, so therefore make sure that you're only plugging into A and B. Doesn't matter which one you plug into which, so I'm going to do 7 squared plus 7.2 squared is equal to C squared. 7 squared is 49, and 7.2 is 51.84. 51.84 plus 49 is 100.84. I need to square root both sides because I want to know what C is, not C squared. So I get C is equal to the square root of 100.84. Okay, you can't do a factor tree for that because of the decimal. So they just want the exact answer. So C is approximately, plug that into your calculator, and you get 10.0 millimeters. The reason it's 10.0 is because they asked for 1 decimal place. Okay? So after 10.0, there were some other numbers, obviously, but they only wanted 1 decimal place, so we leave it as 10.0. And that is it. If you watched this video and you want some extra credit, on Monday, come tell me in secret that my favorite number is 11, and I'll give you extra credit on the next test. But don't tell anybody, because the less people, the more extra credit it'll be.